recording
You need it as well.
this session. Okay, I'm Dr. Zaria. I'm associate professor teaching at the University of Maryland Park campus. And I'd like to ask all of you to please introduce yourself, tell me more about yourself, and then your familiarity with any statistical package. And very short, 30 seconds. Can start with Jasmine. I see you. Jasmine, do you want to go first?
Yes. I'm in the Air Force. I'm using the statistical package at RStudio. And I started the assignment. It's kind of challenging, but hopefully this will help.
Okay.
I'm on my way to Vancouver right now.
Thank you, Jasmine. Beth, do you want to go first?
Okay. Hello, everyone. My name is Beth Colayan. I'm a few classes shy of graduating. I also find this class challenging, but hopefully I'm going to get a lot out of it.
Okay, which package do you use? Do you consider to use for the class?
I've uploaded RStudio.
RStudio. Okay, thank you, Beth. Who is James Weathers?
Hey, how you guys? Can you hear me?
Yes.
What's up, everybody? I am. I'm using Excel.
Okay, perfect, James.
I downloaded RStudio, sir, but I like Excel better.
Okay, no problem. Thank you. I see LIJOW. Who is this?
Hi, Lisa. Can you hear me?
Hi, Lisa. Yes.
Hi. So this is, I will be graduating one more semester that I cannot wait for. I find your class so far to be hard. Sorry.
Okay.
I've downloaded the RStudio, but still have not gotten it to work. I have tried on both the Mac. Now I'm using the Windows, and I think I may just have to use Excel.
Okay. Okay, so thank you, Lisa. John, can you hear us?
Hello, everyone. How are you? My name is Joan. I am a practice manager for one of the hospitals in orthopedic department, and I have downloaded the R file, but I'm not sure if I'm going to be able to use it yet. I'm still watching my YouTube videos so we can get through the user error.
Thank you. Your operating system is Mac or Windows?
It's Windows.
Windows. Okay, thank you. Hida? Hida, can you hear us? You are muted.
Hey.
Hi, Hida.
Hey, so I'm Heather. I currently have a hybrid position as a nurse and nurse informaticist. I graduate next semester. I'm using Windows, and I'm going to attempt to use RStudio.
Perfect. Thank you very much. And I really like the topic you have chosen for the individual assignment 1 and 2. And please let's schedule another meeting here and to talk about your topic after this meeting. So we can, please send me an email. Let's talk about that because that is really, really interesting topic.
Okay, sure, I can do that.
And yeah, thank you. Okay, class. So for today's meeting, I'm going to review our Studio X for exercise 1, and then I'm going to go through the Excel, and then I'm going to walk through the individual assignment 1 with a few examples. At the end, you have 15 or 20 minutes to talk about any possible question you have. And between my presentation, it's okay if you want to, ask your questions. Let me go and share my screen and then walk through this. This is my screen. Can you see my screen? Can you see my screen? Right?
Yes, I see.
Okay, perfect. This is our studio environment. Our studio has 4 panels. This is the panel, I call it code panel. This panel on the right-hand side, on the top. This is the data panel. Any data set you can see in this. The below one is a plots panel. You can see any plots here, and this is the console. Usually the console is the place to see any of our studio outputs. It is possible to change the space between each panel. For example, if you click here in the vertical line, you can go to the left or right. sometimes you need that to see entire observation, or if you want to see more in the console, you can change it vertically, horizontally. So you can just go up and down, just click in the middle, go down, go up. Click on this, right, left. This is very important because most of the students, after using the DPLYR package, they're gonna have a problem with seeing all the results. And I assume that the students who are using the RStudio, they already have installed the RStudio. So if any of you have not installed RStudio, have any question, let me know. I'm going with this default that you already have the RStudio. You download the codes from the class, and now you want to use this code to get the results. This is my assumption. So these are the codes. This is the codes for week 1. And if you go to the class, this is the class, right? This is the class. If you go to the discussion, under the class instruction, you see E1, exercise 1. And for the exercise 1, you have a data. This is hospital, HMGT400 hospital. You have an RStudio code for DPLYR package, and you have RStudio code for no DPLYR package. And this is a video to show how to use this in Excel and in RStudio. The Excel part is the end of this video. And these are all of the questions. So if you click on this, you see a Word document, and the Word document includes all of these weekly exercise questions. So these are the, for example, the week 1, you should answer this question number 1, table 1, populate everything here. For week 2, this is week 2, exercise 2. For week 3, exercise 3, table 3. For week 4, regression model, different models, and for week 5, you have a logic model. So this is all the questions. So it is possible to use the class and for the question, but my recommendation is just go with the easiest ways and then download the question from this discussion, go to this class and instruction and download this exercise from you. Okay. And this is the exercise, a step-by-step guideline. Please make sure to download this and review this. In this guideline, I'll explain every piece of the information for individual assignment 1 to 5, with an example from this from the RStudio. So the first section is about how to install the RStudio, and then the second section is some example from the weekly exercise here. Started from page number, see, this is a long document, but it started from here, page number 29. You see, how I explain how you want to do with this and compare your results with this. By the way, if you are using Excel, still number of observation and mean are very, very similar to RStudio. Maybe your standard deviation should be changed a little bit, and the p-value, not the p-direction. So make sure to watch this, look at these two documents. So let's go back to RStudio. If you download the codes from this here, this is week 1 codes, right? Click on this. So first thing first, data set. Right click on the data sets and save link as or save target as. Depends on different system, you may have a different results. when you settle save link as, go to drive C and make sure to create a folder on drive C and call it this folder UMUC. I know the name of the university changed to UMGC, but call it UMUC because all of the code is based on the UMUC. And then save this file here. As you see, the format of this file is the comma separated values file. This is the format RStudio is easier to read by the RStudio. So the format of the code is based on the CSV file. So if you are using Excel, make sure to change the format of the CSV file to the Excel. Otherwise, when you close the file, all of your formula will be disappear. James, this is really important for you. If you are using Excel, make sure to change the format of the CSV file to the Excel file. Otherwise, you're going to lose all of the formula you have used after closing the file. Okay, so you have, for now, so you have a drive C, UMUC under drive C of your computer. You should put everything here. I think everything's including the HMGT400 data sets and exercise and the codes here. So I put it on the Dropbox because I'm using with different computer. So whenever I'm using any computer, I can run these codes. But it doesn't matter. You can just please put it in the drive C UMUC of your computer. So it's really soon for you to change the location. So this is whenever you open the RStudio, the system should be like this. You don't see anything here, so you click on the file here, click on the file, click on the open file. I put all of my code in the Dropbox, but you should have it as C UMUC, and this is the code, right? This is the RStudio code. I'm opening this file, and you see something like this here. And this code has a different parts, but let me explain this because it is important for the first time if you are using the RStudio. This is the sync command. The sync command works as a log file. The log file is all the environment of the RStudio. Basically, RStudio keep everything you are performing on RStudio as a log file. So I open the log file here, the CUMUC, and after running the code, all of the activities will be saved as a TXT file. And the RStudio will call it week 1 exercise in drive C of your computer at the folder UMUC. Because this is the first time you are using RStudio, you should install the DPLYR package. To install the DPLYR package by default, I muted the install package codes in the class codes. So you should unmute this. To unmute this, remove the pound sign from here, highlight this one, and click on run. It will take a few minutes for the first time to install the package. So I'm not running again here because it takes a few minutes. I don't like to stop system working, but you do it for yourself. Whenever you install the package and you copy the file, HMGT400 file, in drive C folder UMUC of your computer, so your file is ready to go. You just need to go and run the file. If you are using the MacBook or Mac, not operating system, your operating system is not a Windows, then this should be something like this. You should copy this from here, this one. If you are the only user of the Mac, the address should be this. Tilde, I call this sign tilde. Documents. It should be something like this, right? This is the space. Documents / UMUC / hospital. This is for Mac users. I muted this one. And this is for in Windows user. So whenever you have, so everything, if you put all of the file drive UMUC folder, this is fine. You just need to install the package, the DPLYR package for the first time, and then run the codes. So let me walk through the codes. The codes has different section. This is a DPLYR package. This command summarize everything for you in your computer. Summarize everything, all of the means. This is the data, and this is the means. Then we have the same for the standard deviation.
Week 2.
But you should make sure that you select all of them together.
And ran.
If you want to use the step-by-step codes. Otherwise, you can run all of them together one time and everything can be populated in the text file. Then this is the t-test. This is the number of observation, and the last part is the plot that shows the means between two variables, between the hospital teaching in 2011 and I think it was 2011-12, right? This is the codes. Yeah, 2011 and 12. Let's back to, so I'm gonna go ahead and run everything together and run one time. So you can select, right click here and select all. All parts of the code will be selected, or you can press Ctrl+A. Ctrl+A as Apple, right? If you are working with a MacBook, should be Command-A as Apple. So, and then run the code, click on the run, and that's it. So if I go back to the drive C, when you see, I will see the codes here, right? If I select, this is here, right? Today is here. We are 5:30 at 5:17 p.m. All of the information you need is here. These are the means. These are standard deviation. These are the results for the t-test for each variables. And these are number of observation. You have everything here for this table. So I'm going to look at this table and populate one of this row, and then you can do it by yourself for the other row. So for this table 1, I have number of observation n, I have a mean, I have a standard deviation for 2011. I have n, mean, standard deviation for 2012, and I have a p-value for to compare the means between hospital beds between 2011 and 2012. If you look at this, I have this here, right? This is the 2011. I have hospital bed 377 for 2011. And for 2012, I have 377, right? And this is the means. This is the standard deviation. I have for 2011, 561. I have 580. And this is the p-value, right? This is the p-value. If you look at the first line, this is hospital 11, hospital beds, right? This is hospital beds. And if you look at the p-values here, this is the p-value. The p-value is 0.09926. I will explain this later. So the p-value report the value of p based on the value of t to see if there is a significant differences between two means of the two population. Any p-value less than 0.05 at the 5%. Any p-value less than 0.05 is a significant differences. If not, I can say there is no significant difference between two values. For example, this, I have p-value 0.9926, and that means there is no significant differences between hospital beds in 2011 and 2012. So I wrote them here. For 2011, I have 377 as a means. I had 561 as a standard deviation. I had 377. I have 580, and I have the p-value 0.9926. I still have two numbers to report here. If you look at this, go to the very end of this code to see. This is a little bit challenging here because there is no label to show which of them, which of the observation is for 2011 and which of them is for 2012. And these values here are based on the order of this table. So based on the order of this table, I can say the first number is, let's roll together here, put them here. And let me put all of them together.
It's less than 5 or 5%.
If you look at this,
then there's no significant difference between.
This is the same as this. For example, 5005, 14, 98, 30, 505, 5005, 1499, 4084, 1500, 4099, 4081, and then the next step is for 2012. So it's the start 5025, 5014. You can keep going to get the other parts. I mean, 30.
Just hashtags.
5025, 5025, 5060, 5001, 17, 5016, and finally 1498. So this is the end part. Otherwise, for the all other variables you have, you can see the label here. So this is the label. Beds 377, 2011, 2012, 1237 for the next part. Number of paid employer 1491. So you can see, look at this. This is the means, this is the standard deviation, this is the p-value. This is one way to look at this. Whenever you have this, all of the information is here. The other part, if you like to, for example, go and do it step by step and see everything here. So whenever you see something in the console, you have all of the values with the code. So for example, to do that, you should mute the sync comment here.
That's discussions.
And
it's subscription.
Run everything here.
Access it through the R file or not through?
I need to mute you, but okay. If you'd like to talk, please unmute yourself. So if you mute this sync comment, you can see everything here. So I have all of the variable here with these codes, and maybe it's helpful for the number of observation here. So you can see the number of observation here. This is for hospital beds. This is for payer, paid, non-paid. So it's very easy to see them here. And this is the last part, if you like to copy. And this panel shows you how the plots, actually the box plots between 2011 and 2012. As you see, if you look at this part of the codes, this is the original table, original plots. And this is the plot after removing the outliers, the few outliers. So this figure compared the number of hospital beds between 2011 and 12, and if you see, if you look at this line, this bold line is a mean. If you look at this, when the means are close to each other, there's no significant differences between these two based on the p-value, but even looking at this plot, you can see this one. To copy the plot, so you can do, if you click on this, can you see the backward and forward? You can move between the plots. So you can also copy this using the export panel. Click on the export, copy to clipboard, copy plot here, and then go back to the RStudio, to the Word document here. Click here and press Ctrl V as a vector, and paste the plot here. This is RStudio for exercise 1. It's very easy to go. You just need to change You just need to copy the HMGT400 hospital in the drive C UMUC of your computer, and then for the first time just install the DPLYR package by running these codes after muting this, and it's very easy to go. It is as easy as just explained here. Any questions so far for RStudio?
I have a question not about the RStudio, but the copying for the plots for exercise 1. When I submitted my assignment, I only copied the plots for the ones that I found had a statistical difference. Is that okay, or did you want the plots for all of them?
Yeah, for the exercise 1, this is fine because I never asked you to copy the plots. So for the exercise 1, all of the class members will receive the full credit for the plots.
Okay.
But for the other exercise, so you should report all of the plots.
Okay, thank you.
Sure. Any other question for exercise 1 using RStudio?
Yeah.
Go ahead, please, Victoria.
So I'm still stuck to where I last left it when you saw it. The issue I have is because I have my computer. I don't know, maybe I'm just not, you know, familiar with the commands with my computer. But Mike doesn't have that Excel spreadsheet. So then when I try to save it, it's not saving for me.
Victor, are you using Mac or Windows?
I'm using Mac.
Mac, okay. I will ask you to share your screen later after my presentation to walk through your problem.
Thank you. Okay.
Sure. Any other questions? No questions? James, are you still here?
I'm still here, sir.
Okay. Okay, let me go through the Excel for Excel users. And this is the Excel file, right? This is the Excel file, and this is the file. I just, I hide everything because this is the entire code, entire data set, right? So I just hide them because I don't need to see all of them here. This is the 3,000 line data, so I don't need to look at all of this data or just perform any function in the Excel. So for that reason, I prefer to hide everything and just keep 1 or 2 lines just to see the name of the variables to walk through them and to perform the function. And again here, this is the entire table here. The things you should do is, you see this is the entire table here. My recommendation for you, James, and for any other class member who are using the Excel is the first recommendation is try to use RStudio because that's a new package and this is the class to learning a new package. But for any reason, if you prefer to stay with Excel, this is completely fine. But okay, we'll copy the table from the exercise 1 from the Word document to the Excel. This is first step. So you should have this table like this here. And then make sure to find the related column for each variable. For example, for the hospital bed, the column is F in my computer. More likely you should have the same column because if you are using the same data set, the column should not change. Anyhow, if for any reason your column changed, make sure to see the name of your column here. So this is the name of my column for hospital bed is F, and then now, for example, number of employees paid is a V as a Victor. Let me hide all of this. I don't need to see all of them here. So I'm just gonna give you an example, James, and then you can go ahead with the entire table. If you look at this T, this is the T value, right? This is a formula to compute the T value. And for this formula, we should have the mean for the first population, and we should have the standard deviation for the for the first and second population, and we should have an N, number of observation. So here, We have an N for 2011. We have a mean for 2011. We have a standard deviation for 2011. The same for 2012, and this is a p-value. Because, you know, this data, James, is a long data. Do you know what is the difference between long data and the wide data?
In a sense, I do. But, you know, when I did the exercise, I only used 10 data sets. I didn't use the all of 2011 and all of 2012. So
Wow.
I just used like from Florida, 10 from 2011 from Florida, and 10 from 2012 of Florida as well too. So I get the
reason for that.
Yeah, because again, to be able to get a mean, you know, of 10.
See. Yeah, because that was a lot of the row. It was not possible to do. Okay, I see, but that's not a real mean and a standard deviation.
I got you.
The portion of your sample.
I got you.
To do that, make sure to hide them, right? Did you see how I hide this? If you let me unhide and just show you. If you click on the row here and go to the very end, press Control End. As long as you are in this row number, you can right click and hide. So it's not possible. Let me go back. Hold the Shift key and right click and hide them. So you see only 2 lines. You don't need to look at entire lines for this. You should have only 2 lines. So your data sets, James, is a long data set. This is the difference between long. Let me show you what's the difference between long, and this is before the class. Any of you know what's the difference between long data and wide data? Any response?
Is it with the E and the long or zeros or stuff like that at the end?
You know what's the differences between long data set and the wide data sets?
No idea.
Okay. This is the year, right? This is year 2011. Do you want to say anything, James? Do you know anything?
No.
You know, this is 2011 and this is 2012, right?
Mm-hmm.
I'm just giving you a few examples. And I assume there is enough, there is the equal observation between 2011 and 2012. And this is beds. This is, for example, 1, 2, 3, 4. 1, 2, 3, 6. This is the beds. This is other variable, any other variable. The long data set, this is a long, I mean, they are appending after each other. You see, first of all, the 2011, and then you see the 2012.
Okay.
But if you have a wide data set, it should be something like this. Year 11, year 12. Beds 11, beds 12. So whenever you have a wide data set, James, you can use the summary function, right? To get the means, to get the sum, or use the average function to get the means for this observation, right? Because this is a wide data set. Let me go, for example, average of this, or any other function, average function for the means, count function for the number of observation, and STD, standard deviation, STDEV for the standard deviation function. Whenever you have the class data set is a long data set. The long data set is, first of all, we have 2011, and then we have 2012. This is like this. You use the command in Excel with a long data set. You should filter the data, filter the part of the code, part of the observation, using the if command. For example, if you look at this, formula section, I use the count if. So I ask Excel, say, okay, look at these, look at the 2011, right? And filter only for 2011 and 12. So look at this column C, filters 2011, and then look at column F and report everything that is not equal to 0. Using this function, count ifs, you can compute the number of observations for 2011. And you can see the same function for 2012. So I'm gonna ask Excel, use counts in function, filter by 2012, and then report any observation more than 0 for this. And it's the number of observation. And then you should go with average if. Using the if function, I'm gonna filter this data based on this, 2011, and then report the average for F2 for this F column. This is for the average, and this is for the average mean for 2012. And then I'm gonna use the same standard deviation .s, and do you know what's the difference between a standard deviation by .s and .p in the Excel? James?
I guess the P would be for the p-value, correct?
No, P should be for the population, S should be for the sample. The P is for standard deviation. S should be for the population. Whenever you have very long data, and it's preferably to use the P. If you have a small data like this with 3,000 observation, you should go with the S. That's the differences. One of the population always is bigger than sample. And you should use this command, standard deviation .s, using the F and filter by the year, and then report this and should press shift control to get this. So you have this one. So with this function, you should have all of this observation. Number of observation, mean, standard deviation, number of observation for 2011, 2012. And you can do the same thing for paid employee. For paid employers, the column is column V. All of the other column is the same thing. Column C is the same, but this column changed, right? You click on this, you can see how they are different. But this is the last piece. The last piece, you should write this formula. You should write this formula to compute the p-value. It is possible to go with the Excel function to compute the p-value. I don't recommend that. The reason is if you change the column, you can get any result, but you are not able to see what you did. So this column, this formula has different section, right? This is the end. So I'm gonna compute this using this formula here. Let's walk through this. This is the end, right? This is this N1 for population number 1, 2011. I can just copy from this. This is the end. I can say equal this one. This is the means. The means is equal this. I don't need to change the means. But I need to compute a standard error because the formula used the standard error, not a standard deviation. And you know what is the differences between a standard error and a standard deviation? Any of the class member, do you know what's the differences between a standard error and a standard deviation? No? A standard deviation, a standard error is a standard deviation divided by a square root of a standard error. So I should write this formula. Look, use this standard deviation divided by a square root. This is this one, right? This is a square root of this. Divided by a square root of this number, and then I can compute a standard error for this variable.
Now, so can I ask you a question?
Sure, James, go ahead.
So when I did that, right, and I think I did mine the long version way, where I subtracted one, then I got the deviation, and then I squared it, whether it was minus or it was positive, I squared it, and then I took the square root of that and got a number from it. that as well too. So I did a long way. You know what I mean?
Yeah, you did a long way. I understand. You did for entire data, basically.
Exactly.
You did by entire data. So actually, you included 2011, 2012.
Yes.
So that gives you some number, but that number is incorrect.
Got you.
The good things about the Excel is you understand the formula behind the t-test and t-value. You have this, so you can do the same thing for the for 2012, and then to compute the t-value, you should write this formula. So this is the formula I wrote here. I exactly use this. I say, okay, minus this one, x1 minus x2, divided by square root of population 1 divided by n, and then, okay, minus x2 divided by s2 divided by n1, and then compute this. This is the formula. So this is exactly this one. If you look at this line here, this is this formula here I wrote here. Whenever you have a t-value, you should compute a p-value, because the question asks you to report the p-value. You can use this comment, TDIST, open bracket, absolute value of the t, and the number of observation here, and number of groups here. We have two groups, the n is 2, and we have number of observation is the observation, the highest observation. The highest observation is 50.25. And then you can see the p-value here. So then you should report the p-value here.
Yes.
This is the way to compute the t-value and the p-value in the Excel. And then you can go ahead with any rest of the codes and compute everything for other variables. So the only changes should be the formula is still the same, but you should change this row for the other values. A little bit long way using Excel, but so some people prefer to use Excel, and this is the way to compute that. And the way I'm teaching this class for the Excel is to write the variable, Excel, write the formula in Excel, except for the exercise 4 and 5 that you can just use the default function in the Excel and compute the mean. The other way, James, is just convert the long data to the wide data, and then go with the usual command. It is not easy, but it is possible. To do that, you can just you can sort the data by year, and then divide the data to 2 sections, 2011, 2012, and then compute each of them separately.
Yeah, that's what I did.
Yeah. So basically you did here. So you actually filtered this data, or just divided the data. What you did you divided the data by 2 sections? Yeah,
about a year's. I saw that long set and I was like, whoa, that's too many. I'll just do 10. So I did 10.
I understand. Okay. That's good to understand the formula, but that's not how to compute the numbers, because
I got you.
Because this is here, right? This is here. You can divide this data to the wide data, to the long data, and then you should have this. You can hide this. And then you can go ahead with the non-if comment, any other comment. I don't recommend that, because if you switch any of them, everything's going to be different. If you sort one of your data set, all of your formula should be disappeared. No recommendation in here, but I always say something, write a code that you can repeat anytime you like. Don't go with a code that you are not able to repeat that in the future. This is for the Excel, but anyhow, if you like to stay with Excel, James, this is completely fine, but try to understand the code. And for each week, there's a video, I explained that, and this video about this code is still in the YouTube channel. Any questions for the Excel users? No? Okay. Okay, any other question for the exercise one, either RStudio or Excel, except for
Hello?
that question? Yes, Lisa. Is it Lisa? No, it's not Lisa. What was the question? Hello? No questions? Okay, if there is no question, class, I'm going to the individual assignment one. And for the individual assignment one, I already approved all of your topic except a few students. Please look at my comments and see if you change your mind. Just not change your mind. If you change your topic, email me, so we don't need to wait to look at the class.
Hello, Professor. I have a question.
Go ahead.
For we people using Excel, are we supposed to, plot the, for the comparison of the graph that you show for the exercise one, are we supposed to, show it in our exercise?
I see the point. Yeah, you know, for the Excel user, this is okay if you compare the means by using the bar graph. And yeah, how compute that? Yes, let me show you how to compute this. This is here. Let me open the Excel. Let's see. This is exercise 1 and 2, and I have this one, right? This is whenever you computed this, I have beds, right? I have hospital beds. This is 376 and 376. I have, okay, you can go with this, right? 2011, 2012. You can use the bar chart here, insert, and use this. See, this is a bar chart, and then you can label this. You can change the label 2011 or 12. Or even don't need to do that. You can just add a label here. Or you can compute this year 2011, year 2012. And add this. Let me remove this and have this caption here. Insert table. So here, this is, I should choose this together. Let me remove this. Yeah. You can add a title here. Figure number 1, comparing hospital beds. This is how you can compute that. Don't go with the entire data here, just go with the result of your table. It's much easier to go with that.
Like mine, I've already submitted my assignment, but I didn't put the graph. So do I need to go back?
No, for the exercise 1, no, you don't need to go back, because for the exercise 1, this is not a requirement for the question 1.
So from exercise 2, we are required to do so.
Yes.
Okay, thank you.
Sure, welcome. Okay, let me save this and keep it for the next students. They ask this question. Okay, let's go to the assignment. There is a step-by-step guideline for individual assignment 1 and 2. Any of you look at this guideline, class? Do you know how to find this? No response? This is the guideline, right? This is individual assignment 1. and this is instruction. Yeah, this is instruction. If you go to the class discussion, under the class instruction, if you go to the very end, you will see the individual assignment 1 and 2 instruction. This is the instruction. This is an example. And these are the data sets. You can use that. So let me look at the instruction here.
I had an issue. Sometimes when I downloaded that Microsoft stuff, it wouldn't come on board. So I had to use one of the last two. So maybe it was something wrong with my computer to be able to download, like it's from Minnesota, the different ones. It said it had a virus or something on it. So I was able to download the dental one or the inpatient outpatient one. But the other two.
You are talking about the data set.
Yes, right? Yes, sir.
Are you using a Mac or Windows? James?
I'm using Windows. A couple of them just wouldn't pop up to go straight to Excel. It said it had a virus on it. So I went to another computer to try to do it, and it did go. But most of the work is on this computer, so I just used one.
Did you have a problem with Minnesota?
Now I'm going to use the Minnesota inpatient outpatient emergency room one. I'm gonna use that one. Surgery.
You know, the reason is if your computer has some software, the antivirus software on that, usually it raises the question because the CSV file is the most popular way to attack. So usually these are the text file, and the hacker puts a lot of codes on this and then attach to any file. And that's the reason your computer raises a question. The best way I suggest you is just right click on the data sets and save link as. And then your computer is going to ask you a place to save this file. Otherwise, if you click on this, my computer is going to open this here. So we're going to go ahead and open in this Excel. It's a default. This is this data set. But if for any reason you are not able to see this data set, and really don't need to see the data set, if you are using RStudio, but if you are using Excel, you should see the data set. My suggestion is just right click, save link as. So I'm going to introduce in some place CUMUC, put everything in CUMUC.
Gotcha.
Have all of your file in one place. See, UMUC, put everything here. I have this file here. I'm not going to save it again. I'm going to save, it's going to be asking their file is here. Do you want to replace? I don't like to replace it. Let's try this. Let me try the other one. It's opening here. So this is fine. It's opening. This is the Medicare national data. This is the MRI procedure. A short data set. Let me close this, don't make you confused. And this is the Minnesota admission. Minnesota admission has lots of valuable here. This is the, if you're looking for, we have two Minnesota. Your Minnesota admission, the other is the Minnesota cost report data. What's your topic, James?
My topic basically to see the difference between cesarean against vaginal birth in emergency.
And do you have the data for this?
Yes, it's not in this.
Okay, so if you have a data, this is fine, you can use that. You know, I converted this data to the CSV file for the Excel, for the RStudio user. If you're using Excel, make sure to save this file as an Excel file. Here, when you save this file, go to Drive C, UMUC, UMUC, and save this file. Change Excel workbook or any other version. Excel 97 2003 if you have using the old version, but should change to make sure that you should change the save file to Excel format. Any name you can call it with any name, but you should change it. Otherwise, you're gonna lose all of the formula.
Gotcha.
Okay, and this is okay. This is example. So in the example, you can use this example, modify the word, and submit your assignment. So this is the example for individual assignment 1 and 2 because they are very similar to each other. The ways I'm looking at this class is just we're gonna look at the, you're gonna submit individual assignment 1 and walk through the individual assignment 1, give you feedback, you fix that. For the individual assignment 2 and submit that. So basically, if you have, for example, a topic for eye exam in the first assignment between black and white, and you have a topic for diabetes between black and white for the second assignment, you can look at my comment and fix your assignment 2 based on the assignment 1 because the structure of 2 assignments are similar. So this is the cover page. And then make sure to add your name here and mention that the date of submission, your name, my name, and then individual assignment 1. And your topic. Make sure to add your topic. I had some students in other class, they forgot to change it, to write a topic, and then I should go back and address them what was the topic. Introduction, go with very short introduction. And method section, go with the method section. So the write your main research question and describe the data. And usually this is the very standard format of reporting hypothesis. There is no significant differences on, and it's different on your topic. You're gonna change that. For example, on number of admission between critical and non-critical hospital. There is no significant differences on diabetes between percent of diabetes between black and white. So this is kind of the standard format to report the hypothesis. You can use this sentence to modify the data sets. You should describe the data set. For example, if you're using the 2019 Medicare national data by county, you should say, I use the Medicare national data by county. This data set is published by this center, has some 3,000 observation. I'm just making these numbers and 10 different variables. So I just use these 2 variables from this data set. And then you should use the table like this to report the variables. For example, this is the 2 variables I report here. What's the definition for this variable? What is the definition of the code, the source of the data, and the year of the data? You are using the method section. Basically, you are using a descriptive analysis and the t-test. You just need to discuss these 2. You are not going to use any regression or anything like that, just these 2. And the results section. For the results section, you should describe your finding. First, make sure to report the table. When you have a table and the figures, you can just use this text, modify the text based on your finding, and report the number of observation, mean, standard deviation, and p-value. This is all you need to report here, and a few plots, maybe a bar chart. If you are using RStudio density plot, if you're using Excel, you are not able to report a density plot, you just need to report 1 graph, maybe bar chart is the best way. The good things about RStudio is you can see the trend, you can see the distribution of your data. For example, in this, I'm looking at the length of a stay, and the label is incorrect. It should be the number of days, not the value. You don't need that. This is an example. You can see there is a trend. There is a tail after the 6 days, and maybe the best idea is just remove this tail and then do the analysis. If you are using the length of the stay, there is a code in the class that I remove that, and then go with discussion, limitation, conclusion, policy recommendation. Make sure to have all of this section and make sure to use the APA format to report your references. This is the structure of the individual assignment 1 and 2. And this is a step-by-step guideline. It's more detail oriented. So look at this guideline too. You can find more information and a few examples of the codes here for RStudio users. For example, this code is about the managing the data sets. So I'm going to walk through one of these codes and then show you how to use that for your individual assignments. So I have a couple of these codes here, and I believe there are some codes in the class. Is there any codes here? Yes, this is the codes here. Mammogram between Virginia and Maryland, between Georgia and Texas, and this is the some of the codes. So there are several different topics. In some topics, you compare the two states. In some topic, you compare two racial groups. And in some topic, you have, for example, length of stay between acute care and non-acute care, or comparing the MRI procedure and PETS procedures. So let's go with one of the topic, and let me show you how to use that. For example, I'm gonna review the percent of hemoglobin between. Any of you have any topic to tell me? I go with your topic. Any suggestion, any topic, except either with a COVID topic. Any topic you have to look at that in our studio? Victoria, what's your topic? You are muted. Jasmine, are you here with us yet? Still?
Yes.
Okay. What's your topic, Jasmine?
Comparing the MRI procedures between clinics and hospitals for all states.
Okay. Okay, let's go with that topic. MRI procedure between clinic and hospital. That's the topic actually. MRI procedure. And I have to load this code. MRI procedure between. Any of you using Medicare data topic here? Any of major data sets? Any student? Let me see.
I'm using Medicare.
What's your topic, Maria?
My topic is comparing average annual percentage of diabetic Medicare enrollees.
Okay. Annual percentage of diabetic. Okay, I see. Between black and white.
Sorry, what was it?
Maria, would you please repeat your complete topic?
Oh yeah, comparing average annual percent of diabetic Medicare enrollees.
Like it's so early, you know, most kids probably won't.
Okay, I know the annual percentage of diabetics between black and white or between two states.
Between black and white, yeah.
I didn't hear the rest of your sentence. Between black and white or between two states?
Between black and white.
Okay, thank you. Jasmine, okay, this is for your topic. Let me show you something. You should go with another and you know, you should use this data. Jasmine, looking at your topic, this is imaging data center. You should download the data from this class here. Imaging data here. This is it. Where is it? Minnesota admission here. This is the data set.
The Minnesota HCCIS?
Yes.
I mean, imaging?
Whenever you have this, you should write this. If you look at this data, this is the data set you have. This is the data, right? This is the data. You don't need to look at this. I'm just trying to see this is the data you have. And then you have to subset your data based on this clinic and hospital. You should, if you look at this code, look at the name of the data sets, name of the variables, and this is the facility type. Actually, you should look at this variable table Minnesota. Facility type. I'd like to show you how to do that. But facility type, this is the facility clinic and hospital, right? You want to go with the clinic and hospital, correct?
Yeah.
And you should go with this clinic. I'm gonna go with a CL instead of clinic. You can choose any name you like clinic. And this is about procedure and the type of clinic. And you can repeat the code for the hospitals. This is the hospital. And okay, this is the data sets. Okay, Minnesota, facility equal hospital, select MR, okay, because there is no state here. Okay, this is the data set here. I just subtract the data only for the clinic and hospital. And let me go with the rest of this code from here to compute that. Okay, this is the data set, right? The clinic, I call it CL. And you should look at the MRI procedure, correct? All of them is MRI procedure. And this is the hospital. This is the mean, right? And you can repeat the same code to get the standard deviation. The standard deviation. And then you can go with the my table command to get this procedure, all of them is procedure, and hospital. And then you can go with the t-test command to get, I don't expect the class you go to so fast like me, but this is all the steps you should go with writing the code. I don't need you to write the code, but in case you'd like to practice, this is the way you can change these codes. And okay, this is here, comparing MR procedures between clinic and hospital. This is the clinic. This is the hospital. This is MRI procedure. Clinic. This is hospital. I'm changing this, just walk through this. I will explain to you later what should I do. And this is clinic, this is hospital. This is part of the code. If you want to update your code, I don't recommend you to do, I don't need you to do that, but like to practice, this is completely fine. So this is the same app. So first of all, I have a data, right? And I should subset the data for clinic, and this command subset the data, and then I should compute the means. This is the means. All of you, for the individual assignment 1, you should record 5 functions. The first function is the mean function to get the means. The second function is a standard deviation function to get the standard deviation. The third function is my table function to get a number observation. And the fourth function is the t-test, the t-test function to get a p-value, right? This is the p-value. The p-value is a 0.79, 7799 there is no significant differences between MRI procedure in the clinic and hospital. And then you can plot that. This is the plot. This is the plot. If you look at this plot, the means are quite the same almost. Maybe because of this variance, you cannot see significant differences. And then you can look at the density plot. This is the density plot, and this is in the left. You can send it to the right, top right, to get it better shape, right? And that's it. This is the topic for you, Jasmine. I'm gonna share the codes with you. You don't need to rewrite again this code.
Okay.
Let me save as clinic, MRI, clinic and hospital. Okay. Let me compare the percent of beneficiary. It was Maria. It was diabetes, correct?
Yes, that's correct.
Yeah. I think I have a diabetes here. Let me open the file. I don't need to write again. Diabetes. Where is diabetes? Lipid, mammogram. Okay, here. The percent of diabetics using the Medicare national data by county. So first of all, you should copy this data, Medicare national data, CSV file on drive C of your computer, and then look at this data set, make sure you have the variables name. So for this part, you have a percent of diabetics black and white. This is the variable here, percent of diabetics black, percent diabetics black here. This variable, so percent diabetic white, and run the same code. So you have the codes here, but should just need to run the codes and get all the results. But if you want to run this, write this code. This is the place you should change. Percent black, percent white. The same thing for my table command, the t-test, my plots, and the density plots. This is for this. And if you look at these numbers here, you have 18, 10, 18%. These are the 10% standard deviation. This is the p-value. P-value 2.2, e on power of -16. It's a very small number. It's going to be 0.000050, 0 and 22. Less than 1, less than 0.001, so it's completely significant. And then you can report this. And this is another example from the Medicare national data by county. If you try to write a code, you can use this code at the very end of this instruction, modify the codes based on what I did here. Or please send me an email with your complete topic, and I will share the codes with you. Okay, I'm finished with my presentation here. I'm here for any question for you. Let me stop sharing. Any questions so far, class? And James and it was one other student who are using Excel, correct?
Yes.
You know, for the Excel, for the individual assignment 1 and 2, it should be exactly like the exercise 1 and 2. You should just select your topic, the variables, and then compute. And because all the data sets, if you are depends on the topic, I don't know what's your topic is it's not a long data because your data set has only one variable. So you can use exactly the average and count, and but you can use the same formula I showed here and to compute the t-test. I will share the file I have in the Excel with you and one of the other students who are using Excel.
I may play around with it. I still have time, you know.
Okay. If there is no question here, Victoria, are you still with us? Victoria?
Yes, I'm still here.
Okay, do you want to share your screen, Victoria, to show me what the problem is with your MacBook?
Okay.
Do you know how to share?
No.
Okay. There's a green button in the menu in your kind of Zoom, share a screen.
Okay.
And click on that and share the screen.
All right.
Please, any other question, class, until Victoria is sharing her screen?
So this is going to be on the R Studio, right? Sharing from R Studio?
Yes, please.
Okay.
Professor, I had a question. So I know you said I could email you so you can share the code, but
yeah, sure. Yes.
From the code, is there anything that I have to like specifically change, or I could?
No, actually, you should only download the data from the class, the Medicare national data from the class instruction, which is drive CUMUC, and then download the code I'm sending to you, and then run the codes.
Okay. Thank you.
Sure.
Professor, is it going to be on the toolbar?
Yeah, on the toolbar, in the menu in the bottom, yes, on the toolbar, you can see a share screen. Or you can press Alt-S as a sample, and you can share your screen.
Yeah, I think that's good.
Didn't find it?
I'm doing Alt and S, but nope. So let me see. Yeah, I'm not finding it. I mean, what I'm seeing here is file, edit, code, view, plot, session, build, debug, profile tool.
Okay, let me share my screen, show you what you see.
Okay.
See my screen? Do you see my screen?
Yeah, at the bottom, okay.
In the bottom, there's a share screen.
Okay.
Click on this.
Okay. Oh gosh, where is it? All right, so go to the bottom.
Thank you so much for holding live session. Okay, great.
It's not showing for me.
Well, you are not. Oh, you cannot share.
No, it's not showing for me on the R Studio. So I'm at the bottom here, but I don't see that option.
Okay, do you want to try again?
I mean, I see share screen on this Zoom, but I don't see share screen where the R Studio. Oh, I see what you mean. Okay, I got it.
Okay. Okay, here you go. Okay, I see your screen. Are you Mac user, correct?
Yes.
You know, okay, I see. You should change a line 14 and line 8. Change a line 14, have you, okay, line 14 should be, okay, look at line 15, can you see that?
Line 15.
Can you read that to see the code? If you are using the MacBook, you should see this number, can you see? Should be a slash, backslash, tilde, documents, a slash. You should copy this. Yeah.
So go as far as here and, oh Lord.
Yeah. Or you can change the line 14 based on line 15, an example I provided too.
So
copy everything in the parentheses.
Okay.
And
with the parentheses or just in?
With the parentheses, and yeah. Okay, do something else, maybe easier. Mute the line 14. Mute the line 14. Do you know how to mute line 14?
No, Professor, I have no idea.
Put the pound sign in front of line 14.
Okay.
Pound, shift 3. Now go to line 15. Remove the pound. And remove everything that if you are using should be. Remove that part.
So this will be from here.
No, not all of this, not all of this. Until should be. If you are working with Mac, the above line should be. Remove this part. Yes. And remove this column also, semicolon. Yeah. Okay. What? Enter it. And fix the documents spell.
You said fix it?
Document should be document, D-O-U-C-E-N, documents. The spell is incorrect, right? That's correct. Oh, okay. Can you just run line 15?
Okay.
Okay. Okay. Do you have the hospital data set in document of your computer?
So I was able to actually open up the documents, yes, but like I said,
can you go back to your computer and show me where's the data set?
Okay.
Please go to your computer document and let me see. You have the data there.
I haven't been able to save it. That's the thing. So I see it right here, but let me come here and see it.
Can you minimize this? Okay, here you go. Where is this? Document is on the. This is the download. Document is here. Where's the UMUC folder?
That's what I'm saying. It doesn't take it. So all of these that are here are my previous classes, documents from previous.
Okay, I see. You don't have them in the UMUC folder, right? You have in the document, correct?
Yeah.
Okay, go back to line 15 then. Close this one. Cancel it. Okay, remove the UMUC after documents.
I mean, but I didn't save anything. So if I remove it, and I'm probably changing the code because I still have everything as you had it in the class. The only difference right now is I open up the documents, but to save it, so I have all of them right here on my toolbar, but they just can't be saved.
I see, but you don't have the folder UMUC in the document. You have, or you can create a folder in that. Remove the UMUC. I like to make sure you have the data in the document.
Okay.
Run this line 15. Let me make sure you have the code. It's not there. So can you go to your computer, not through the RStudio?
Okay.
Go to your computer, minimize the RStudio. And okay, class, do you have any other questions here? Because I'm gonna work with Victoria to fix this problem, so you don't need to stay here with me. If you like to leave, this is fine. You can leave the Zoom session, and I'm gonna back with Victoria to solve this problem.
Is this live session going to be on YouTube, Professor?
I will post this, yes, tonight.
Oh, I'm sorry. Can you remind me when can we schedule personal meetings with you?
I didn't hear what you say, Maria. You say where it should be the second.
Are specific days we can schedule meetings with you? One-on-one.
You broke up. It's really hard for me to hear you, Maria. I'm sorry. Can you be closer or just talk louder? I can hear you.
Can you hear me now?
It's perfect now, yes.
Okay, I was wondering when can we do one-on-one meetings?
Oh, I see. Please send me an email. I will schedule a meeting with you.
Okay, thank you.
Sure. Okay, Victoria, please let me close this meeting and back again to the meeting. I will fix your problem.
Okay, thank you.
Class, thank you very much for your participation.
Thank you.
I'm closing this meeting now. I will post the session on the YouTube and share it with you in class.
You want snacks, Zoe?
Okay, thank you very much, class. I'm closing this meeting. Victoria, please back to me. Back to the live session. Thank you, James. Bye.
Bye-bye.